It's good to have you back. We are going to jump into chapter 14. As we could have guessed, after differentiation comes integration. So chapter 14 is going to be all about multiple integration. So we have functions of several variables, and we're going to be doing integrating of those functions. Very similar to how we did with partial derivatives, we're going to treat any variable other than the variable of integration as a constant. So we will integrate with respect to our variable of integration, which is always indicated by the d, and anything else we're going to treat like they're constants. Now we have to think about a little other piece to this. If we remember when we did indefinite integrals, so the integrals without bounds, when we had something like the integral of f of x dx, well, we would get the antiderivative, capital F, and that little extra bit, right? We get a plus a c. These aren't unique antiderivatives. You get that family of antiderivatives where all they differ by is a constant, because whenever I differentiate this side, if I differentiate that antiderivative, that constant, no matter what it is, goes to 0 because the derivative of a constant is 0. And so we get this little f of x in that case. So now when we think about when we have a multivariable function, if I have f of xy, well, what does that plus c look like? Well, obviously we could still have plus a constant, a true constant, an actual scalar. But remember, there are other things that we treated as constants. So for instance, if we think about it, if I had something where I have a function and I'm taking its derivative with respect to x, any scalars, when I take the derivative, will go to 0, but also any expressions that don't have x's in them are going to go to 0, which would include functions of only y, or expressions that have only y's in them. So when we take the antiderivative of this little f of xy, we're going to get an antiderivative, capital F, of xy. So we'll get a function of x and y, but then we're also going to get plus a constant, but it's going to be a constant function of y. Now, part of that constant function might be a piece that is a scalar, but it also might have pieces to it that have expressions in terms of y. Later on, we'll practice some examples where if we're given enough initial conditions or enough information, we might be able to determine what that constant function looks like. But in general, we have to keep in mind that it's not just a scalar constant, it's a function of whatever variables we weren't integrating at the time. So let's practice an example. Let's say that we want to do the integral of 2xy, and we're going to do it dx to start with. So my integration variable is just with respect to x. So when I pay attention to this then, anything that's not x, so something like 2 and y, we're just going to treat as constants. You don't have to take this step, but if we want to, we could even really emphasize that. They literally can get pulled out of the integral because constants can come out in front of my integral. So this could become the integral of 2y times the integral of x dx. So the only thing left inside is my variable that I'm integrating with respect to, which we then know to integrate x with respect to x, well, power rule says you increase that power, right? And then divide by that new power. So we would have x squared over 2. And now we have to remember to add on our new fancy constant. So we have plus a constant function of y. We can clean that up just a little bit too, and divided by 2, we would have yx squared plus a constant function of y would be my final antiderivative for this function. As we move forward, we're going to do lots more examples of this. I instead could have integrated that function with respect to y if I wanted to. We also, what we can see next is we can do definite integrals. So rather than having no bounds and needing a plus a constant, we can add on bounds, and then we'll get a final answer, which will no longer have my variable of integration as a part of it. As we're integrating with definite integrals with bounds, we'll pay attention to the idea that those bounds need to be constant with respect to the variable of integration, but that means that they might be functions of other variables. So we'll see that in a second here in our next video.